Welcome everyone to this breakout session on the designer tools. In this session I would like to introduce you to two client use cases that were implemented using the designer tools of our Abacus platform. Furthermore, I would like to present the tools, but first I would like to introduce myself. My name is Matthias Polle and I'm a senior business consultant at Regnology. I studied economics and business administration in Tübingen and international business on the finance track in Maastricht. For the last 4 years, I've been part of the advisory team at Regnology. During this time, I've supported our different clients on our supervisory and statistical reporting modules in Germany and Luxembourg. One of my focus areas for some time has been the application of our designer tools at NordLB Luxembourg Covered Bond Bank, who agreed to let me present our joint work here today. NordLB Luxembourg Covered Bond Bank SA is part of the NordLB Group and specializes on issuing covered bonds according to Luxembourg law, called Lettres de Gage Publique. NordLB CBB uses not only Abacus360 banking for regulatory reporting in Luxembourg and Germany, but also Abacus360 Risk for the ILAP Pillar 2 requirements and the Abacus Lima tool for simulating the forward LCR. As already said, the designer tools are a central part of our current project work at NordLB CBB. Before we start with the use cases, I would like to talk in more detail about our different designer tools and their capabilities for those of you who had not yet worked with them or heard about them. Our designer tools consist of the data model designer, the calculation designer, and the template designer. The purpose of the data model designer is to define new entities and database fields. This can be used to extend the standard Abacus360 data model by introducing new client-specific entities and fields for various purposes. These new entities and their respective fields can be used, for example, as additional input fields or to store the results of new business logic on the database. But how can you create new business logic to use or fill these new fields you defined in the data model designer? This can be done in the calculation designer. You can create new business logic as functional units using SQLX, our domain-specific Spark SQL dialect. The logic created in the calculation designer can fill the tables that we previously defined in the data model designer. Finally, the template designer can be used to create customer-defined reports very similar to spreadsheet solutions like MS Excel. However, these templates can be filled automatically using allocation rules that can be defined in the template designer. Using these allocation rules, the template can be filled with the data that you already store on the system or just calculated. The templates are visible in the user interface, just like our own regulatory content. All in all, with the designer tools, we provide our clients with 3 powerful tools which can enable them to create their own Abacus content. At NordLB CBB, the designer tools are used in multiple capacities. In this first use case, they are used to integrate the ETL, which stands for Extract, Transform, Load, into Abacus360. This is also sometimes called pre-processing. This means that instead of the entity tables of the Abacus360 data model, NordLB CBB defined their own input data model. They deliver the data in tables using field names and values that resemble the structure of their feeder system or data warehouse via XML file. The data is then transformed using the business logic built in the calculation designer into our 360 data model. This mapping exercise can be implemented almost completely in the user interface of Abacus360 using the designer tools. The target solution for NordLB CBB also involved a few noteworthy additional key features. The solution can calculate different outputs depending on the reporting country and the accounting standard in question, using the same raw input data. This is, for example, required to correctly implement the delivery of book values in case of fair value hedges in different accounting regimes or for different reporting requirements. This is done by delivering account postings instead of pre-calculated book values and aggregating them only where applicable. Meaning the implemented solution can calculate some values and create additional records as required based on parameters like the reporting country and the relevant accounting standard. The content in Abacus360 is bundled together into components. These components contain the data model definitions, business logic, and templates when applicable. You can see in this graphic how the data flow of the FinCube2 Abacus360 component, which performs the ETL, looks like at NodLB-CBB. The input entities were defined using a similar naming convention to the Abacus360 data model. Their names always start with BV, so for example BV position, BV instrument, BV partner, etc. However, the fields and values in these tables are not yet transformed into the Abacus360 data model's field names or valid domain values. All of these entities and fields were set up in the data model designer. The data is then transformed using more than 250 functional units and over 50 decision tables into the standard Abacus360 data model. As already mentioned, in some cases, which of these functional units are triggered depends on the parameters chosen when processing. Finally, the entity tables in the standard Abacus360 data model are filled and ready for further processing. Our second use case at NodLB-CBB is the creation of multiple additional reports for liquidity gap analysis in Abacus360. In the standard, Abacus360 Risk generates cash flows based on different prolongation and stress scenarios. Based on this, the liquidity risk solution already contains standardized templates for a liquidity gap analysis for the purpose of ILAP Pillar 2 requirements. However, NodLB-CBB asked our advisory team to support in the creation of additional liquidity gap analysis reports and templates that could be used for further analysis and provide the basis for reporting these more granular liquidity risk figures to their traders and for the NodLB group's own ILAP. The solution has the following key requirements. First, the different contractual, economic and behavioral cash flows need to be aggregated for different liquidity risk management product groups, considering all defined scenarios, dates and currencies. This aggregated information must be accessible in the system via a specific database table, so the different liquidity gap analysis reports can be quickly accessed via Excel export. This way, a detailed overview over the liquidity gaps of all different risk management product categories can be created and the specific product groups can be analyzed quickly. Second, a standardized template must be filled. This template consists of two parts. On the one hand, it contains even further aggregated liquidity risk figures, mainly focusing on refinancing risk and how different stress scenarios affect these. On the other hand, it contains an extended liquidity gap analysis. This is the template you see here on the right. Finally, specific reports must be generated and exported as CSV files to be sent to NodLB's parent company. We did this with additional CSV reports that we created using custom MPE jobs, meaning we combined the previously existing functionality of custom MPE jobs with the designer tools. The designers prepare the data, the custom MPE jobs only extract it and create the CSV files as specified. Here you can see the setup of these additional reports. On the left you can see an oversimplified version of the Abacus360 risk data flow for the liquidity risk solution at NodLB-CBB. The raw data is imported and transformed using the previously discussed ETL process. Cash flows are created based on scenarios defined and parameterized together with the raw data by risk. Using these created cash flows, the liquidity risk solution can calculate the required results to fill the standardized ILAP templates. The business logic of the liquidity reports component is used to fill the different custom database tables based on contractual and economic cash flows that are delivered by the feeder system and that originate from systems like Mirax and is transformed by the ETL, as well as the behavioral cash flows that are generated by Abacus360 Risk. The liquidity reports component also uses result data tables that were calculated to fill the ILAP templates. The business logic of the component mainly filters and aggregates these cash flows and does that for different product types or currencies. Some of the functional units prepare the data for the standardized RTF template. Finally, the reports in CSV format are created by a custom MPE job that extracts the data from the custom database tables. For the third part of this breakout session, I would like to show you these tools and then explain what the basic steps are to set up your own custom reports in this demo. Now, on this test system here, you can see immediately that something changed. On the top menu item here, you can find a menu item here that's called Custom Reporting. And by accessing Custom Reporting, you can access one of these templates that I talked about before. And for the second template here, you can see that actual cash flows are allocated here already. And these are not some sort of manually typed in fake numbers. These are actual cash flows. You can even drill down into one of these cells here and see that something got allocated. Another thing that you can see in the system is that if you go to data, you can see here on the left navigation bar the different report the different custom created database tables. So for the ETL, you have these BV tables that I previously talked about in use case 1. And for the liquid reports, you have these custom result tables. Now switching to the designer, you can see on the left here a lot of different components. These are all components from the standard Abacus content, but you can search here and find the liquid reports component, for example. You can see here it's only imported for release 760. And by opening up the component, first thing you find here is dependencies. Now, first of all, you can create a new custom component just by clicking on this left button here, new, and type in your new component if you want to. The dependencies of this component means basically content from the standard Abacus content that you can access with this component and reuse certain parts of the content here. So for example, we have here the base functions and risk valuation liq, which is the liquidity risk solution. In the component overview, you can find what sort of data you want to import and process in this component. So for example, you have here the dataset name cash flow in, which is basically the standard Abacus360 data model entity cash flow, and it comes from a synthetic source component called input, and therefore it has this suffix here cash flow underscore in. These are all tables that you can access later when you want to use them in the calculation designer. But first, in the data model designer, you can see the entities that we've set up. We distinguish here between two kinds of entities. We have report data entities where we store the results of the calculations that are used to fill the templates from the template designer. And you can have regular entities here. The report data entities are a little more standardized. You can see here that they have, for example, the row name and column name and the amount here that are allocated on the template, while the normal entities here are completely customizable. So here you have all of these fields that you see here, they are created in this data model designer, and you can do that by clicking here on field, type in a field name for your new field. And then you can assign different parameters to the field. You can make it nullable. You can make it a primary key. You can store it on the database or explicitly say that it's not stored on the database. And, which is important here, you can assign a domain. So the domain is the valid values for this field. Here you can say, for example, that it's a string with a maximum length of 10 characters. You can also create custom domains here for these fields. And here you can define, for example, a list of valid values that you can type in here in the lower part. Now switching to the calculation designer, you can see here functional units and datasets, and for this component we do not have any decision tables. If you look at a functional units are basically the SQLX code, the business logic of this component here. And you can see the functional unit basically is declared here first. Then the import datasets are defined here. These are the same import datasets that I showed you before here in the component overview. But you can also name other functional units in here, or to be more precise, the datasets that are exported from other functional units. And now you can see that here in this functional unit there are different selects made, and conditions are made for these selects to get the result effect. So here, for example, a cash flow for a specific risk management product type is aggregated based on currency, scenario name, and date. Finally, you can see here in green this command to update the table log spaces. So we have to create a record before in another functional unit, but afterwards we can update it. And a dataset is exported in the end. Now switching over to the template designer. You already saw the template for the liquid reports component. This is created here as a template set. Now in this template set we have two parts in the same template. Looking at the template designer, you can see here menus, modules, allocation sets, and template sets. Let's first look at the template sets. So when I open this up, you can see the RTF template that I showed in the beginning. And you can configure this template basically like a standard Excel, but you can also upload your template and export the template that you designed here. You can upload them here, for example, import template set. But how do you fill this template with content? For this, we use the allocation editor. And we have here in this template two allocation sets. And you can see here, this is for the lower part that is already filled. We defined here allocation rules. So what is allocated? This field CFV278, and it's aggregated here. And what is allocated? It's based on these calculated maturity bands here. To create an allocation set, you first need to define a report range. And this report range you can define here. It's basically the blue area here. In the origin cell, that's this one here, this is where the allocation starts here, the area where data records can be allocated. And you can see here these allocation sets are linked to this report range, and it is linked to a functional unit and to the result table for these liquidity reports. Now the other items here, the allocation sets, we just showed you how these are calculated. The module basically also connects the report again to the result table, but this here is for loading the report. And finally, you create a menu item here. Now, after having looked at the system and seeing the designers in practice, I would like to finish this presentation by talking about the advantages of the designer tools over custom homemade data processing solutions. First of all, with the Abacus designer tools, you are able to respond quite quickly to external or internal requests for data or reports like ad hoc requests or fire drills. Especially if these reports are not that complicated, an experienced user can create them in a matter of hours or days. This way, you can also automate these reports if you need to create them regularly for certain departments or management functions. Another key advantage is that you can reuse the data and calculation results that you already have in the system. You already have the key regulatory figures and the key risk figures there. You have the raw data there that you can access. And you can reuse it. Reusing this data makes it so you have a single point of truth in the final stages, as all the manual corrections like last-minute accounting adjustments, they should already be in there as well. Finally, with the Abacus designer tools, you can leverage the key functionalities of the software. What I mean by that is that you already have a user authorization concept in Abacus and a reporting hierarchy. So you can adjust and amend these to include the custom reports and make sure that only the people who are actually supposed to see this data or these reports can access them. Comparing that to your homemade data processing solution, you may think, why not just do a query on the database, put it in a folder, create Excel reports from that extract and send them around via email. But using Abacus, you have a much higher degree of security as a built-in functionality. You also have the audit trail functionalities of Abacus. So you have audit-proof changes, and every manual change can be reviewed by the auditor. You have report that you can extract for the auditors, and this all can be done for both internal and external audit requirements. Finally, especially when you work with large amounts of data, spreadsheet solutions come to their limits. Using the designer tools in Abacus, you can avoid these problems. Especially when you have large amounts of data, we had the example of cash flows in use case 2. Spreadsheet solutions can come to their limits and take a long time to show you the data that you actually want to see. For example, considering lookups over multiple tables. I would like to end this presentation by thanking again the team from NordLB Luxembourg CBB for their support. If you want to have further information on the designer tools, especially from an advisory perspective, feel free to get in touch with me or my colleagues. Thanks again, and have a nice day at the Rector Convention.